key contribution of statistics is the ability to make comments about a population without assessing or testing all elements within that population. For example, if trying to estimate lifetime of batteries, we cannot test every single battery in the factory, else there would be no batteries left to sell. Instead, we select a sample and test them. We may then infer information about the whole population based on the sample. Similarly, in health, we may be interested in how long it takes for a painkiller to take effect. Clinical trials may involve a sample of people under strict conditions consuming a tablet form of the painkiller. Many factors may influence the time for the tablet to take effect, for example, a person's sex or age, or the time since their last meal. However, we can determine the expected or on average time for it to take effect for a given set of conditions, for example, being male and age 30. We may be interested in testing whether or not the mean time is 15 minutes, for example. By this, we really mean whether the true population mean time, that is the mean across everyone requiring a painkiller, would be 15 minutes. We state this as being our null hypothesis, the value we wish to test. We need some data to test this. Our random variable could be called time, measuring the time to take effect, and we may measure this across a sample of, say, 200 people currently suffering from pain. Each person currently suffering from pain is given the tablet, and the time until the pain is relieved is recorded. Let's say we found the sample mean time, based on the 200 people, was 15.0001 minutes. That is, the average across the 200 recorded times, one for each person, was 15.0001 minutes. So, is the sample mean of 15.0001 minutes far enough away from the tested population mean, 15 minutes, to reject 15 as being the population mean? We'd probably feel that 15.0001 is close enough to 15 that we wouldn't reject 15 as being the population mean. What if the sample mean, the mean time across the 200 people tested, was 15.1 minutes? Would you then reject the population mean as being 15 minutes? What if the sample mean was 15.4 minutes? Or what if it was 16 minutes? Or 17.3 minutes? Or if it was 2 hours, 120 minutes? At some point, you would intuitively say that the sample mean is so far away from the null hypothesis's value, 15 minutes, that you would reject the null hypothesis. So we are interested in whether the sample of data reveals a sample mean that is so far from 15 that you reject the population mean as being 15. So how far is too far away? We don't want to guess or simply use our intuition. The sample mean we obtained, based on a sample of 200 people, is just one of many possible sample means, depending on which sample of 200 people were considered from the larger population. There is actually a distribution of the possible means we could obtain for a given sample size, in this case, samples of size 200. The null hypothesis states the population mean of this distribution is 15. If all individuals give very similar times, then we also get a tighter distribution of possible mean values. If the individual results vary greatly in time, then we get a much wider distribution. Whatever the amount of variation, we then want to know the probability of observing a value for the mean as or more extreme than what we observed, if the true population mean was 15. So if our sample mean is 16.4, we want to know the probability of observing something as or more extreme than 16.4, if the true population mean was 15. That's what this area represents, the probability of observing a sample mean as or more extreme than 16.4 if the true population mean was 15. So, the smaller the remaining area, the more likely we are to reject the null hypothesis, as a small area indicates our sample mean is a long way from the population mean we are testing. This area is referred to as the p-value. In practice, we compare the area, which is a probability and hence a value between 0 and 1, with what is known as the significance level. A commonly used value for the significance level is 0.05. If the area, the probability, is smaller than the significance level, we reject the hypothesized mean as being the population mean at that significance level. Else we cannot reject. Whilst there are many nuances to this method, This has hopefully given you some insight into the hypothesis testing process.